Good morning, ladies and gentlemen. This is Mr. Green. I'm making another one of my recordings to give you some lessons here. Where we are? Well, let's see here. In the whole scheme of things, we're still in Unit 1. Okay? Should all be finished through Unit 1 and the midpoint exam. Okay? The midpoint exam was after Unit 10 or after Lesson 10. So you should all have completed that. Now, don't forget, you can still submit quiz corrections if you didn't get everything correct on it. So just make certain you're correcting the problems and showing me exactly how they worked and submit them to the corrections drop box. Due dates, remember, in about 28 days, the first week's worth of lessons will close, and then 28 days after, that, the second week's lessons close, and so forth. So things close up on you pretty quickly. Don't get caught not getting them done, because if you don't get them done, no way I can go back and help you, okay? So let's look at what we're looking at today. What we're looking at today is some terms that we're going to be using. They're nothing more than terms, okay? What we're doing is we're trying to come up with a way of identifying where a point is. And we're going to use some of the construction things that we've already done to help us come up with that term, okay? So what have I done here? I took a line segment, BC, and I took a little compass, and I drew a line putting my compass point on point B. I drew a little arc, and my arc, let's see if I can do this freehand, looked something like this. Okay? And then I put my compass point on point C, and I didn't change it any at all, and I drew my arc, and it looked something like this. When I'm doing that, I'm getting 2 points of intersection. One right here and one right here. And if I draw a line in between those 2 points of intersection like this, it goes straight through the center. I'm off a little bit. Sorry about that. Goes straight through the center of the line segment. What do I mean by center of the line segment? Well, that is simply the point that is, there it goes like that. That is the point that is halfway through line BC. It's called the bisector. And because of the way I constructed it using this construction method, it makes a 90-degree angle here. That 90-degree angle right here, see it right here, 90-degree angle? That 90-degree angle makes this a perpendicular bisector, okay? If I do that to all three sides, make a perpendicular bisector on each of the three sides, and I'm going to erase my construction points here so that they're not in your way, so that you can see what I'm talking about. Hang on a second while I erase my poor construction that I did. There it goes. If I do that on all three sides, I get three perpendicular bisectors, and I draw those three perpendicular bisectors out. Here's one here, here's one here, and here's one here, and they meet at this point right here. They'll all three intersect right there. That perpendicular bisector, I'm just going to give it a name, O. I identified that point. Why did I need to identify that point? Because that point is a center of a circle. As you can see, the circle here is drawn for us in red. You notice how it goes through points A, B, and C? It hits each one of the three vertexes of the triangle. It is related to the triangle, and it hits each one of the three there. This type of a circle is called, or this type of a point is called a circumcenter. Circumcenter, because it circumscribes or goes around the outside of the triangle. Every triangle has one. It's a point that causes a circle to go completely around the outside of it. Nothing special about the triangle. Every triangle has one. Another point that we might want to find might be the incenter. Incenter. That is inside of the triangle. Now let me show you. What we're doing here is we did a bisector again, but we did an angle bisector this time. And I bisected angle A, and I came up with this line right here. And I bisected angle B, and I came up with this line right here. And I bisected angle C, and I came up with this line here. And the three lines meet right here at this point. If I draw a circle at this point, I can get one that would fit exactly inside of the circle. Now the incenter will always be inside of the triangle. The circumcenter over here could be outside of the triangle. It could be inside the triangle. It could be right on one of the edges of the triangle. It depends upon the type of triangle it is. The incenter will always be inside of the triangle because the circle always fits completely inside of the triangle. Incenter. Okay? All I'm doing is identifying where this point is right here. Okay? Got it? Circumcenter. Identified this one. Perpendicular bisectors. Circumcenter. Incenter. I'm identifying this point right here. It's inside of the triangle. Completely inside of the triangle. Okay? For this next one, it's the third one we're going to do. All I'm going to do is find a point here, P, called the centroid. Centroid. That's a kind of an interesting word. Notice there's no circle associated with that one. That's because this one is not one that is has a circle associated with it. It is simply a balancing point. Notice how I have taken a triangle, any triangle whatsoever. I am taking it and I'm finding a point from point A down to the midpoint on CB down here. That's what that line segment is. Now, how did I find that? If I took the edge AB and put it right on the edge AC over here and lined those two up and folded the triangle, it would make a line. It would find that line. That line is called a median, okay? Because it goes from the vertex of one point to the midpoint of the side opposite it, okay? Let's see here. See if I can make this work for us here. I'm going to try to do this. Okay. Let's try that. Let's try this. Okay, you all should be able to see me now, okay? I'm sitting here on my couch in front of my window here, and I have a triangle. See my triangle? Nothing special about my triangle. I've taken it and I'm going to fold, and I'm folding one side down so that it touches the other side, and I formed a median, okay? There's one of my medians. So if I unfold my triangle, it's now creased on here, and you can see where the median is. You might not be able to see it in the video there, but I can see where the median is because it's creased on my piece of paper. If I do another one, I'm just going to take a side and I'm going to fold it down here. Okay, I now have two medians. You can see it's folded onto here, and I've got a point where both those two medians intersect. What this point is where those two medians intersect, is a balancing point. I can then balance this triangle at the centroid of the triangle. It should balance on my finger just like that. TD. So you wonder, how do people get those things to balance on their fingers sometimes? They're using the centroid of a triangle. It's a very simple technique, okay? There, that'll do that. Okay, so hopefully you guys learned something today. I want to make certain you're aware of a couple of other facts. When you're sending me K-mails, I have 300 some odd students right at the moment, and if you want me to try to respond to you quickly, you need to include your course name and what section of the course you're in. Mr. Green, what section of the course am I in? I don't know what section I'm in. Well, if you look at your course right up here in the top right-hand corner, it says section number, okay? So if you look at that and tell me what section you're in when you're communicating with me, it would be much helpful. That way I can get a response to you very quickly. Okay? What we've looked at today is we use constructions to explore some geometric attributes of geometric figures, to make conjectures about geometric relationships, and formulate and test conjectures about properties in parallel and perpendicular lines based upon explorations and concrete models. Those are right out of the TEKS. These are things that they expect me to teach you. Okay? Hopefully you enjoyed it. Hopefully you learned something. What you will be asked in your questions will be, I'm using perpendicular bisectors on the sides. What center am I finding? You're finding the circumcenter. I'm using angle bisectors. What center am I finding? You're finding the incenter. Hopefully that helps you guys.